Hey, what's up, GRE lovers? So, someone basically texted me in a private chat this question and asked for its solution. I found it quite intriguing, quite interesting, so I thought, why don't I make a video about this? Okay, so here it goes. It says Professor Franklin can have all five of his graduate students, Albert, Billy, Carly, Dennis, and Emily, accompany him to the research conference. Okay. Alternatively, he can decide to take only four, okay, three, two, or one of the students. How many of the possible groups of graduate students attending the conference include Carly? Okay, so this is definitely a combination problem. How do I know that? Because of this word right over here, groups. So the professor is trying to group things up, combine things up, so order does not matter. And furthermore, I noticed that there are different, the strength of groups is different. Like he can select a strength of 5, 4, 3, 2, and 1. And I'm interested in not just any group, I'm basically interested in those groups which basically include Carly. Okay, so I think this question needs to be done in by step approach in which we have to consider different cases. So definitely my first case would be, okay, so if this is the total strength in which I have A, B, C, D, and E, in which I'm definitely interested in C. So the first combination, I'm just going to go in order in which all, let's say, 5 out of 5, all 5 are basically selected, okay, and basically combined. So, I mean, this question can be approached in a in a more interesting, or you can say smart way, in which, in one way, I could simply go for a direct approach in which I can find the combination in which C is there. However, I can come up with a more indirect approach in which I can say, okay, why don't I find the total possible combinations and subtract the combinations which does not have C, and that will ultimately lead me to the groups which has C. Okay, so in my first case, I think it's pretty much obvious that there is just one grouping possible in which all of them are going to be selected, in which I will have A, B, C, D, and E, right? And I mean, you can simply use the combination formula if you like, but I honestly wouldn't recommend that because it's pretty obvious. So over here, there is just one possibility in which C is definitely going to be in the group. Okay, moving on. Let's move over here. And next, I'll choose 4 out of 5 people. And now I'm basically interested in a group in which Claire is definitely a part of that group, right? So what I can do over here is like, why don't I go for an indirect approach and see what happens? So definitely a 5 combination 4 is gonna give me what? Yeah, 5, right? Oh, I can just prove it just to make it, more interesting. Let's see. Okay, so I have 4 dashes. Okay, 4, 3, 2, and 1. And then I have 5, 4, 3, 2. All of this cancels out, and I'm left with 5 total combinations. Now, let's be careful about this. These combinations basically include certain groupings in which Claire is definitely not a part of. So this is basically the total. So now the question is, okay, is there any possible combination which does not have C? Well, definitely, yeah. If there are, let's say, 5 elements and I need to pick 4 of them, well, there is a possibility, let's say A, B, D, and E. Now, this combination over here does not have C in it. So it is one case, one grouping possible, which does not have C. And since I'm interested in grouping which has C, what I'm going to do is, okay, why don't I subtract that? 5 minus 1 equal to 4. Now, these are the combinations which definitely have C. I think I need to move down a little bit. Now I'm going to go for the case in which I can pick 3 out of 5, okay? So again, I'm going to go through the indirect approach in which I'm going to go for the total, subtract the cases which does not have C to eventually lead me to C. So a 5 combination 3 will be just, okay, 3 dashes, 3, 2, 1, 5, 4, 3. Okay, 3 goes out with here. 2 times 2. Okay, so I have 10 total possibilities. However, I'm interested in a certain group which basically does not have C. So I can say, okay, so this is the total strength, right? A, B, C, D, and E. Let's cancel C out and make our strength A, B, D, and E, okay? And now, since I can only pick 3 of them, I can use the symbol combination formula again. I'm like, okay, for combination 3, which is just gonna be 3, 2, 1, 4, 3, 2. This cancels out. I get a 4. Now, this is the 4 which basically does not have C. So I'm just gonna simply subtract 4 from 10 and eventually get a 6 right over here. These are the combination which does have C. Okay, moving on. Okay, same procedure. 2 combination 5. Okay, so what's going to be the total? So the total is going to be 5 combination 2, which will eventually lead me to 2 times 1, 5 times 4, which is going to lead me to 10 possible cases. However, since I am not interested in C, what I can do is, okay, why don't I consider this strength, okay, and just pick 2 of them. So 4 combination 2, what I'm going to get is 2 times 1, and eventually 4 times 3. 2 ones are 2, 3, 2, okay, 6. Now I can just subtract 10 with the 6, 10 with the 6, and get a 4. So far, so good. And now, finally, the last case, which is I'm selecting 1 out of 5. And this is just simple common sense because the only way I can grab a group which has just 1 member, and that 1 member needs to be C is, I mean, come on, it's C itself, right? C. And, well, you can use a combination formula, but I think it's just it's just not really working over here. So it's just pretty obvious because we're only interested in C. So this is just going to be simply one case, right? So now that I have all my numbers ready, the thing that I need to do is add everything up. So first of all, I'm just going to add this one, then eventually this 4, then I'm going to be, okay, what's next? Yeah, then it's going to be a 6 right over here, then it's going to be another 4 over here, and then it's going to be the last one. Okay, so I'm going to be like, okay, 1 plus 4 plus 6 plus another 4 plus 1. And once that's going to be, this is going to be 10, this is going to be 14, and with these 2 2's, it's going to be 16. And if I come back up, yeah, the answer must be